So for this first one, it says use the formula 1 over f is equal to 1 over p plus 1 over q to find p if f is 15 and q is 25. So similarly to what we did in the previous section, we're just going to plug in 15 for f, we'll plug in 25 for q, and then we'll multiply by the least common denominator, which is how we learn to solve rational equations. So this is going to turn into 1 over 15 is equal to 1 over p plus 1 over 25. I'm just going to ask you, if anyone would know, what the least common denominator would be. The smallest number that you could divide by 15 and 25, 75. Very good. We're going to multiply every fraction by that. This would be 75p times 1 over 15 is equal to 75p times 1 over p plus 75p times 1 over 25. In the last section, we were able to cancel out factors. One thing, I'll just show you a little bit of an easier way to do this. You could write the denominators underneath the outside term. So let me show you what I mean. We could just write this 75p over 15 times 1 equal to 75p over p times 1 plus 75p over 25 times 1. So if you don't have factors that cancel out, 75 divided by 15 is just 5. Seventy-five p divided by p just cancels. And you just get 75 plus 25 goes into 75 3 times. Finding our like terms, we get 2p is equal to 75, or p is equal to 75 over 2. We'll also write 37 and a half if you want. That's totally fine just like that. Moving to problem number 2, we want to solve for q, and we have all variables in the denominator. So the way that we solve a rational equation is we look for the LCD. We would need a factor of p, we need a factor of q, and we need a factor of r. Just because there's no numbers doesn't mean anything changes. The LCD would just need a factor of each of those letters, which will multiply times each fraction. similarly to what we did before, at this stage, we just cancel out factors if you're divided and multiplying by the same thing. We wind up with just Q times R times 1 plus 3 times R times P is equal to 5 times P times Q. Remember, we're looking to solve for Q, which means get Q by itself. Yeah, so let's get all the Q's on the same side. So we're going to get everything on the same side. I'll bring this 3RP over, and I'll bring this 5PQ over. So I'll subtract 5PQ, and then I'll subtract 3RP on both sides. Wait a minute. Oh, I'm sorry, guys. I meant to put a 3 here. I got a little excited. Thank you, Liquid. Just by rearranging our terms, we get 3QR minus 5PQ equal to negative 3RP. Take out for that. What's that terrible soup called? It's like a red sauce. Helios, what's it called? You know what I'm talking about? It comes in a can, has all little letters in it. Yeah, SpaghettiOs, that's what it is. Well, remember, we want to get Q by itself, and right now it's inside of two terms. So one thing that we could do to separate it from them is to factor out a Q. If you factor out the GCF of Q, we get 3R minus 5P. And we're almost done. Factoring was key there, because now we could divide both sides by 3R minus 5. And we'll get Q is equal to negative 3RP divided by 3R minus 5. Moving to problem 3, it's similar. We want to solve for R. Now it looks like we have R on top and bottom. So one thing that we could do is multiply by our least common denominator of big R plus little r. We get A times R plus R equal to R plus R times big R, little r over R plus R. Cancel. We get AR plus a little r is equal to big R, little r. And it's similar to what we did in the last problem. We want to try to get it on the same side, and then we'll factor it out and divide. So what I'm going to do is I'll bring the AR on the other side by subtracting it. I'll bring big R on the other side by subtracting that. Get AR minus RR equals negative AR. factor out the big R. And then divide both sides by the other factor. And that would be what R is. A couple of these problems, you'll see the steps are mostly the same. You multiply by the least common denominator. If you have the same variable in two terms, we factor it out and then divide. For problem number 4, it says 4 out of every 100 Alaskans had no health insurance. Alaska's population was 742,000 at that time. How many Alaskans had no health insurance? So it looks like we have to set up some kind of proportion. So proportion is one fraction compared with another fraction. So it looks like we had 14 health insurance out of 100 total Alaskans. So ratio is just a way to compare two different things. We're saying for every 14 with health insurance out of 100 total. So if we want to try to figure out if there's 742,000 total, how many with health insurance? So really all we have here is something called a proportion. The proportion, part is just setting them up. We want the top to be the same type of quantity. And once you set it up correctly, all you do to solve a proportion is do something called cross multiplying. Multiplying with cross. What a cross multiplying means to solve a proportion is we multiply along the diagonal. 14 times 742,000 is equal to 100. Calculator 14 times 742,000 is 103,88123. I'll divide both sides by 100 to get x by itself. X is equal to 3,808. The number of Alaskans out of 742,000 that have health insurance. 14. Let's keep going. We have 4 more problems left and about 15 minutes to go. For problem number 5, Lauren uses 15 gallons of gas to drive 390 miles. She has 6 gallons of gas in the car, and she needs to drive 800 miles. How many more gallons will she need? So this is another example where we have to set up one ratio that says how far will she get on 15 gallons of gas, and then compare that with if she already has 6 gallons. So she already has 15 gallons. And that allows her to go 390 miles. And we're looking to go 800 miles. I have to get a little bit creative with the numerator here. Go on top. We're Trying to figure out how many more she has to add to 6. She already has 6. How much more? So I don't know. I'll use X for that. And then we'll just cross multiply to solve this proportion like we did the last one. 15 times 800 is equal to 390 times 6 plus X. 15 times 800 is 12,000. 390 times 6 is 2340. 390X. Using some basic algebra. 390X is equal to 12,000 minus 2340 is 9660. Divided by 390 means she needs to get 24.8 more gallons. More to go here. Plane travels 100 miles against the wind in the same time that it takes to travel 120 miles with the wind. The wind speed is 20 miles an hour. Find the rate of the plane in still air. Something like this is on your review guide for the next exam. It's also on the exam. If you want to start this one off, this is pretty much the same thing as what you'll be tested on. When we're talking about speed and we're talking about distance, we use the equation d equals r. The distance you travel is equal to your speed times the number of hours that you're traveling at. So we'll say with the wind, that's going to make us go faster. If you're flying and you have a with the wind, you're going to go a little bit quicker. And then we're going to have against the wind. With the wind, we're going 120 miles. And that would be our speed plus the wind speed. Against the wind, we're going 100 miles. And that would be our speed minus the wind speed. So find the rate of the plane in still air. What this means is we need to come up with some kind of equation where we're solving for r. It asks us to find the rate. We want to have r as the only variable there. You see how it has in the same time? What this means right here is we're going to set the time equal to the other time. Let's solve for time for each of these equations. The first one, if we divide by r plus 20, t is equal to 20 over r plus 1. That's with the wind. Against the wind, that time is equal to 100 over r minus 20. The times are the same. What this means is we do 120 over r plus 20 is equal to 100 over r minus 20. We have a proportion. We talked about how to solve that. If you do it on your own, we'll just cross multiply. 100 times r plus 20 is equal to 120 times r minus 20. Distribute 100r plus 100 times 20, 2,000 equal to 120r minus 2,400. R on both sides, 2,000 on both sides. Negative 20r is equal to negative 4,400. Dividing by negative 20 gives us 220 miles per hour. Is the rate of the plane without any wind. Couple more problems. All right. A couple more problems. Donna drove 300 miles north from San Antonio. She averaged 55 miles per hour, but an accident slowed her rate to 15 miles per hour. If her trip took 6 hours, how many miles did she drive at the reduced rate? So let's talk about this. If distance is equal to rate times time, that would mean that time is equal to V over R. And as far as our trip is concerned, if we map it out, it looks like she averaged 55 miles an hour, but an accident slowed her rate to 15 miles an hour. So what that means is for so long, we'll call it X miles, she drove at 15 miles per hour. And then for the other bulk of her time, traveled at 55 miles per hour for 300 miles, however far X is. The whole trip is 300 miles. Part of that she traveled at 15, which means 300 minus X she averaged at that other 55 miles per hour. The way we're going to solve a problem like this is if the trip took 6 hours, that's equal to the time without traffic plus the time with traffic. So equal time for that first part of the trip would be the distance over the speed. The time for that second trip would be the distance over the speed. A little complicated to set up, but that's what we do. The LCD for this, if we are looking to solve a rational equation here, between 55 and 15, it would be 825. What we'll do is we'll multiply that times each fraction and then solve for x. And I'll just do that on the side here to save us a little bit of room. So we're going to do 825 times 6 is equal to 825 times 300 minus x over 55 plus 825 over 15 times x. $25 times 6 is $49.50. 25 divided by 55 is 15. 25 divided by 15 is 55. I'm just distributing and simplifying here. That's equal to 5 minus 15, 40 x equal to 450 divided by 40 is 11.25, or 11 and a quarter hours. Let's see here. We're looking at how many miles. So 11 and a quarter miles. We're solving for. I went a little over. We had a lot to cover today. For this last problem, it says Jerry L needs 45 minutes to do the dishes, while Winnie could do them in 30 minutes. How long will it take if they work together? All right, so this is an easy problem. Let me show you how we set it up. Say that work is equal to rate so for Jerry L, the way we set it up is one job is equal to his rate times time. And Jerry L needed 45 minutes. Work that to hours. Which means that his rate would equal 1 divided by 3/4 or 4/3. That's Jerry L's rate. Winnie do one job at her rate time to do them in 30 minutes. 30 minutes, half an hour. So if we divide both sides by 1/2, we get her rate would be one job divided by 1/2 or 2. If they're working together, what we're going to do is we're going to say to do one job together, that's equal to the rate of Jerry L plus the rate of Winnie times how fast it is for each of them, and if they're working together, that's like twice as fast. Let's go ahead and solve this. together, it's just going to be one job is equal to Jerry L's speed was 4/3. Winnie's speed was 2. Looks like all we have to do is just combine those together and solve for time. 4/3 plus 6/3 is 10/3. And then dividing by 10/3 gives us a time of 3/10 of an hour. Or 3/10 times 60